All right. I just started recording. Okay. Hi, everyone. Thank you for joining our first online workshop of the school year. So today we have Samuel joining us to present choosing a Google Cloud Compute resource. Samuel is a software engineer with a background in electronics and electrical engineering, and he's currently pursuing his master's degree in computer science. He's also a certified associate Google Cloud engineer. So I'll pass the floor on to Samuel with his Google Cloud workshop.
Hi everyone. It's so great to be here today. Thank you, Vivian, for the invitation. As Sam, I'm a software engineer. I'm currently pursuing my master's degree at Memorial University of Newfoundland, studying computer science. I have quite a number of years' experience working as a full stack engineer. In addition, I've worked on architecting solutions on the cloud using Google Cloud specifically. And in this workshop, I will be touching on the topic choosing a Google Cloud Compute resource. The mode of this workshop would be me giving an introduction into what cloud computing is in general, the various service models that are available in cloud computing, and then I would relate these service models to various products on the Google Cloud platform, and also share some demos on how you can easily create all these products and push your applications to the internet. In case you have any questions during the course of the program, please let me know. You can put it in the chat, and I would be glad to touch them. So let's get started. Uh, Also, in case you see me looking this way, this is just my screen on the other side, so don't mind me. Okay, a quick introduction into what cloud computing is. Cloud computing is the on-demand availability of computer resources or your data, your computing power, hard disk, without you directly managing it. This is a way for you as a user to have access to computers without having to deal with the complexities of managing the physical resources, having to deal with electricity, ventilation, and so much more. And this gives us a good insight into the various service models that we have for cloud computing. Um, in recent times, you must have heard about SaaS, especially software as a service. A lot out there creating various applications which they term as SaaS. It's a popular word and it's a service computing model we'll be touching in this workshop. We also have the function as a service, platform as a service, which are all known as the serverless platforms. We have Kubernetes as a service for our kids developers, and we have infrastructure as a service. Um, so for the first one, software as a service, this is an application that is delivered over the internet by a provider to you. See your Google email, your Google Calendar, this platform we are using currently. These are all softwares that has been provided to you by a provider, which you don't have to write any code. You don't have to deal with the backend infrastructure. All you have to do is log in into a URL and access the features that has been made available. Of course, some of these features may require you to have some subscriptions, but the entire model is driven about you not having to do an installation, you're not having to specifically have a computer where you install the application onto. You can access it anywhere over the internet. Um, and then the software as a service is just a general review, so we see where we are coming from. I would be moving forward into much more service models, which are developer oriented. And the first one on that part would be the function as a service. The function as a service, popularly known as serverless, is a model that allows customers, developers to run their code without having to deal with the complexities of managing a backend infrastructure. It allows you as a developer to push your code out in forms of functions and get code to respond to certain events, certain requests, and also scale automatically. So this service model, an example of it, as we can see on the Google Cloud Platform, would be the Cloud Functions. So what is Cloud Functions? Cloud Function is the fully managed serverless Google Cloud environment where you as a developer can deploy your apps, you can deploy your functions and get them to respond to various events. One of the great features of Cloud Functions is that it scales automatically. You don't have to worry about adding various server infrastructures to attend to growing traffic and so much more. There are quite a number of environments, which are actually two right now. We have the first generation and the second generation. The first gen is much more older, and the second gen is newer, which supports much more features, allows you to take much more processes at a certain time. Cloud functions were designed to work in an event-driven environment. By events, I mean respond to certain actions, respond to certain triggers in your cloud environment. These triggers could be HTTP based. They could be certain. They could be triggers from things like your cloud storage, your Google Cloud pops up, or the official Google messaging platform for cloud services. And also, it's good to know that cloud functions are able to integrate very well with other third-party services easily. In terms of costs, you only pay for the resources you're using. So when you deploy your application as cloud functions, you don't get to pay until people are actually using them. The times at which you don't pay anything, you only pay for what is used. So what are the use cases of cloud functions? One of the most common use cases is using it as serverless mobile backend. When you're just building out your application, you have various functions that respond to various features, your authentication, making some processes. You can use cloud functions for that. When you have to deal with topics with regards to PubSub, publishing and subscribing to various topics, you can use cloud functions. And this is because cloud functions is heavily event driven. Another use case for cloud functions would be processing files in real time. So say you've uploaded a file to your server and you want to perform some aftermath processes like changing the file formats, doing some compressions. Cloud functions come in very handy in cases like this. Also, you can use cloud functions for your IoT backend. Uh, as we know, the Internet of Things depends so much on sensors, on actuators, a lot of edge devices, and all these systems are event driven because you want to perform certain actions based on the data you got. You want to update your thermostat based on the temperature and so much more. And having to deal with all these complexities yourself, having to scale your server yourself based on the traffic you're getting from your sensors is quite hard. And that is where Cloud Functions performs very well because it scales automatically and it was built to respond very well to events. So say you have millions of devices sending out data at the same time, Cloud Functions is able to serve them appropriately. And there are some cons of Cloud Functions, which is that it supports just a limited number of programming languages. If you want to use some other programming languages, you might want to explore other products, which I will still mention in the course of this workshop. Cloud Functions can only be triggered with HTTP and certain events. And also, it's because it offers function level granularity, you're unable to actually bundle entire app bundles into it. You are you'll be constrained to only working with your functions and deploying them and having to manage them. This can add additional complexities on the long run when you have to manage, say, like hundreds of functions, having to check the logs for each of these. These are some of the cons that come with cloud functions. Um, so after discussing each of these products, I would go on to show a quick demo of what I just said, so it can be more practical. And a demo of this would be a demo of cloud functions. So on the Google Cloud Platform, um, as a student, I think for everybody, you're able to sign up for free and get some credits as a trial. So you might want to check this out after this workshop to try out some of these demonstrations. So I'll be creating a function now, a simple function that just responds to HTTP request, and we'll see how quick it is for you to deploy your functions and make it available over the internet. So as I mentioned before, we have two environments, the first gen and the second gen. And we can see that in the first gen, it supports just one request, which is not concurrent. Second gen supports much more. The second gen has much more execution time, which allows you to like do much more processes before it times out. It supports more regions and it allows you to split traffic between application versions. So So for your cloud function, this is how you would normally write out your code. This is a simple function that just responds to a request from an HTTP URL. And this will be the real life scenario of you actually using it and seeing how fast you're able to deploy it. This takes some few minutes to just start up initially, but once that is done, uh, it handles the auto scaling for you, the load balancing, the SSL termination. So as a developer, you don't have to worry about all these, and you really don't even have to have a specific systems engineer on your team. Why this is still loading, we can see that it has generated the trigger URL for us. And I would also like to show some other event types, some other event triggers. You can see that you can use the Cloud Pub Sub, which is the messaging platform. You can use cloud storage. This is quite useful for after upload file processes. You can use the Firestore, responding to uh, events, responding to inserts, responding to data changes in your Firestore database. You can even use it for your Google Analytics, which is very good for marketing applications where you need to perform certain actions based on how users are using your app. Okay, this is our function. And by clicking on this link, I can easily access it at anyone in any part of the world because obviously it's on the internet, would be able to access it. So this shows how fast you're able to deploy a function as a part of your application. This is very useful for your mobile backends. So the second service model we'll be looking at is the platform as a service, PaaS. So this is a model that allows developers to deploy full app bundles in the cloud environment. You are able to deploy not just functions now, but actual app bundles. But you still don't have to worry about the complexities of managing the backend infrastructure. You don't have to worry about the load balancers, the networking, the routing, and so much more. And the examples of these on the Google Cloud platform that you can make use of is the App Engine and the Cloud Run. I'll give a quick general overview of the App Engine, which is a serverless platform for deploying your app bundles at scale. It has two major types of environments, which is standard and flexible. I will go into details of those later. It supports app versioning. And what this means with supporting app versioning is that you can deploy certain versions of your app, such as version 1, and it also allows you to split traffic amidst these versions. A very good scenario of this is when you have an existing app and you make an update, but you're unsure of how it would interact with the user usage. You would want to roll out these updates gradually. And with that, you can easily split traffic amongst the application versions. Out of the box, App Engine supports SSL. It supports SSL termination, which also means it does the load balancing for you under the hood. It works well with systems that are built with the microservice architecture. It supports quite a number of programming languages out of the box. That leads us to the first environment of App Engine, which is the standard environment. Um, this environment uses a sandbox of whichever programming language you've chosen. Say you've chosen JavaScript, it runs your application in that sandbox. And because of this, it allows you to scale your application very fast. By running it in the sandbox, it means some part of your application, the runtime environment is already up. And by you pushing your code, it is able to quickly scale your application, quickly serve it to your customers. And it is designed to run for free. In cases where you don't have any usage, it's not running. In cases where you don't have any traffic and the app is idle, you're not charged for it. And when you are, it only provisions the resources that you need to serve the traffic. This is very good cost-wise, making it very, very cost-effective to use. Also, because of the fast startup time, because of the swift development, good for applications that would be experiencing sudden and extreme traffic spikes. So say you are working on an app and you're quite unsure of how how the traffic would be like at certain periods of the day or certain seasons, you might want to explore the App Engine because it makes sure your application is ready and responsive in times of extreme traffic spikes, which would lead to zero downtime most of the times. The second environment for App Engine is the flexible environment. This is quite useful, especially when you want to deploy applications with programming languages or specific dependencies that are not supported by the standard environment. Uh, it is great for applications that receive consistent traffic, not applications that might receive sudden spikes. And the reason for this is it takes a bit of time for instances running in the flexible environment to start up. So you want to be sure that you're using this environment for applications that will be receiving consistent traffic, the ones you can predict. Also, it cannot scale to zero. And it's worth to mention that the flexible environment supports WebSocket. The cloud functions we had mentioned earlier support HTTP and other events for the triggers. The App Engine standard environment, it supports just HTTP. But when you have use cases where you have to use WebSockets, say you're dealing with a chat application where you have to ensure you're processing information in real time, and you still want to make sure you're using a serverless environment where you don't have to do so much configuration, the App Engine flexible environment is for you. So use cases when you need to develop your web application swiftly, when you're deploying static websites, when you want to deploy applications with different versions and also manage the splitting of traffic between them. When you want to deploy applications that need to scale automatically based on traffic, this would be your best bet to use. So a quick demo of the App Engine. So for you to deploy on the App Engine, you must have had the Google CLI set up locally. Doing that now might take a bit of time, but I will just show you a quick example of an application I had deployed with various versions and how you can see the feature that allows you to split the traffic. So right here in this Hello World application, I have deployed 3 versions of the app. And with a quick overview, you can see the traffic allocation. You can see that a particular version is resumed 100%. But let's say I want some users, I want to start doing some testing with a new version of the app, I can easily split the traffic between certain app versions and select the number, the percentage of traffic I want to go to that particular version. This allows you to perform rolling updates and ensure that if there is any case where your app is not performing the way it should, you can easily just revert, and then it would not affect all your user base. It should just be a certain percentage. So you can use the IP address of your customers to split the traffic, cookies, and so much more. So this is a very app engine and just shows some general um, features, especially the splitting of traffic, which is very useful when dealing with various application versions. The next,
Sorry, Samuel, to interrupt. I'm seeing a question in the chat. I'm not sure if you've already answered it.
okay, any AI support engine. Okay, so while we are going through this, I'll still talk about compute resources you can use for your machine learning and your AI applications. Thank you. So, so some of the differences between Cloud Functions and Cloud Run. When we're looking at the Cloud Functions, we would see that, sorry? Oh, so I've not talked about Cloud Run before. So Cloud Run, I missed that. Cloud Run is a serverless Google Cloud environment for you to deploy your application containers. Compared to App Engine allows you to deploy your app bundles itself. But when you have use cases for using containers, and the reasons you would need containers sometimes is when you have to add some certain dependencies, you want to make full use of the containers feature, you need some other network protocols. That is when you use containers. And Cloud Run is a managed serverless Google Cloud environment that allows you to deploy containers easily. Also, it supports fast auto scaling. You're also able to split traffic between your app versions, the same way we did with the App Engine. And for in terms of payment for Cloud Run, you pay for actual CPU and memory used. When the application is idle, you don't pay for anything. But when it's you pay for the CPU and memory that is actually used during the period of usage. And Cloud Run is very good for applications that are stateless, applications that don't need section management, that don't need sections to operate. When you're dealing in a system where you architected your application in a serverless mode, and you also need specific runtimes. Of course, it's good for web services, backend services. Another thing to note is that with Cloud Run, it supports concurrency out of the box, and this makes it possible for you to take full advantage of programming languages such as Java, Golang, and make use of the concurrent features in them. Cloud Run is good for scheduled services. Say you're running some batch file updates at a period of time, and because it supports this concurrency, you can make sure you write your application, you program in such a way that you take full use of all these features. And one major one major constraint to note with Cloud Run is that you must use containers. So unlike the App Engine where you have to just bundle your application itself, your app.js or your Python file itself, for Cloud Run you must actually have images that you're using. You must have built your image and then you use the image URL, which can be hosted where you want, maybe on the Google Container Registry, on any other public cloud registry that you want to actually run your application. And I'll go through a quick demo of how you can create um, you can create your resources on the Cloud Run environment. So as I mentioned, Cloud Run it uses containers only, and I'll be using a very simple container that's already been built, an image that's already been built for an Hello World application here. And you would see here that you can choose the CPU allocation you want, choose the number of instances. This scales down to 0, which means when there's no traffic at all, you're not being charged for anything. And when there's a need for traffic, it scales to a maximum of whatever you put here. Um, you can do some minor configurations regarding, do you want traffic only from your GCP resources? Do you want it from your cloud load balancer? And so much more. So I'll create a simple app here. It's worth to mention that Cloud Run also supports triggers where you can use specific events from various services such as cloud storage, your Firestore, your Google Analytics. You can also use it on Cloud Run. And because it supports concurrent processes, this will be very good to check out for a lot of workloads. So this is our application fully deployed, and we can see it's running here. It's SSL terminated, and you can also set it up for continuous deployment, continuous integration by using other services such as Cloud Build. Um, so far, we've talked about a couple of cloud computing service models. We talked about the software as a service, the basic such as Gmail. We talked about function as a service where you deploy functions and you're able to trigger it using various events or using HTTP. We talked about platform as a service, and we gave examples of App Engine and Cloud Run. The next one I'll be talking about would be the differences between cloud functions and Cloud Run. Because while talking about these products, you would see quite a number of similarities. It's also worth to mention the differences between them and know when best to use them. So for cloud functions, it allows the deployment of functions. This is some kind of constraints when you need to deploy actual app bundles. But with Cloud Run, you're able to deploy actual container images, which also contains custom dependencies you might have configured in your application. Cloud Functions is limited to certain programming languages, but with Cloud Run, because you're deploying an actual built container image, it allows you to run any programming language you want. Also, it is worth to mention that the first generation of Cloud Functions, it has a lesser timeout. And out of the box, Cloud Run offers much more. This is good when Cloud Run offers much more timeout, and this is good when you need a product that performs various data manipulation over a longer period of time. You want to be sure you're using a product that has a longer timeout. Also, because of the concurrency that Cloud Run offers, it's able to send and manage multiple requests to a container instance, unlike the Cloud Functions first generation, which only serves one request at a time. So the next I'll be talking about is the Kubernetes as a service um, cloud computing model. And this is a model, I think I should talk about Kubernetes at first. So Kubernetes is an open source container orchestration platform. It allows you to manage container clusters, manage the nodes, and manage the communication between all your containers. And this cloud computing, when it comes to cloud computing now, this service allows you to not worry about managing the backend infrastructure yourself now, but rather just putting up your Kubernetes clusters on a platform that manages it for you. And an example of that is the Google Kubernetes engine. So the Google Kubernetes engine makes use of the Google engine under the hood. I'll talk more on the Google Compute engine later on. And also to answer the question we had earlier about which compute resource you can use for AI, you can use the Google Kubernetes engine. And the reason for this is it allows you to specify certain resources such as GPUs, which you need for your AI workloads, your machine learning workloads. So the Google Kubernetes engine is a very good compute resource for you to use. Okay, so this is a managed environment for you to deploy, manage, and scale your containerized applications, of course, without having to deal with the complexities of the backend infrastructure, having to deal with doing your routing. It offers a lot of these out of the box. It consists of a lot of compute engines on that you'd group together to form these clusters. And because it's built on the Kubernetes open source platform, you're able to take advantage of the full features of Kubernetes and even use the commands you would use in your typical Kubernetes environment on the Google Kubernetes engine. Also, it helps you to manage your nodes and also auto scales for you as needed based on your traffic. So the general use cases for the Google Kubernetes engine include when you have applications in multiple environments or cloud, when you have to ensure your application performs in a consistent way, which is why you're using containers in the first place. And you need to like still make use of the Kubernetes features. When you need to when you need to work with various networking protocols beyond HTTP, WebSockets, Google Cloud events that we had mentioned. Also, it is useful when you want to add things like GPUs, TPUs, configure specific RAMs for your workloads. This is where Google Kubernetes engines come in and is very handy. And it's also worth to mention that when you have a team, it works well with large teams where you have specific DevOps, software dev, security teams working on specific features, and they have good communication between them. Google Kubernetes engine is a very good product to use in such cases. The constraints is that containers must be used, which means you must have the knowledge of Docker, containers, and so much more. And Kubernetes itself is a bit complex, which means that your developers must have to, they would have to like get some how this works, and also you would have to weigh your options to know if this is really worth learning or if you can just go with the other options we've mentioned before. Setting up a GKE cluster might take a bit of time, but I will just show some of the general features on it for creating one. So there is an autopilot one where Google manages everything for you, and there's a standard one where you still have to do some other configuration. This requires much more skill set, much more experience to be able to configure. For the autopilot that Google offers, you can out of the box quickly choose the type you want. Do you want these clusters to be accessed only in your private network or your public network? Do some network configurations and even add some encryptions and so much more. So these are some of the things you can do easily with the Google Kubernetes engine. So whenever you're working in a Kubernetes architected environment and you're looking at putting your application in the cloud, the Google Kubernetes engine would be your best bet to look out for. So the last service model I'll be talking about is the infrastructure as a service. And this is a model where uh, computer resources are provided by a service provider to you, and you're able to configure them as you want, and also do extra provision extra resources as you may want, but you don't have to deal with the physical complexities. You don't have to deal with the various connections, the various physical networking, and so much more. But this provides you all the resources you might need, such as routing, load balancing, firewalls, and so much more. This is the infrastructure as a service. And a good example of this is the Google Cloud Engine. And the Google Cloud Engine powers a lot of other services we had mentioned. As we mentioned, this is where the Google Kubernetes engines actually run. But Google has already they're already doing the configuration and managing all those things for us, where we don't have to worry about the backend connections and so much more. But when you want a model where you want to perform specific configurations, you have certain requirements, you want to configure it in your own way, looking the infrastructure as a service model would be your best bet. And that leads us to talking about what the Google Computer Engine is. So this product allows you as a customer to create and run your virtual machines. So before virtual machines, I believe there were bare metals where companies had to have actual servers lined up in their server rooms. And if you as a person wants to deploy your application and ensure you're maintaining high traffic, you have to get much more servers and pay and have them shipped to you. But with a product such as Google Compute Engine, with a click, you are able to get any type of machine you want, any type of machine with any disk crate attached or not, you are able to have it at a click. So the Google Compute Engine offers scale, it offers performance and value for your money, especially when launching very large clusters of machines on the cloud. Uh, each VM you have can have up to 224 virtual CPUs, 1,792 gig of RAM, 64 terabyte of disk, and 8 GPUs attached to one. Having to get a physical machine that would do this require not just setting it up require time in terms of even getting it over to where you are, having to manage it and ensuring it's not overheating and so much more. But with VMs, you have this provided for you easily. And also, there are specific machines that has been configured for workloads that you want. So, say you want a machine that is suited for artificial intelligence processing, graphic processing, gaming, and be it just simple web services. There are machines that are specifically built to do this. It also supports GPU accelerators where you need to handle computationally intensive workloads. And it's also mentioned that with all these great features that come with it, it starts quickly too. From you provisioning it to you running your actual code takes about 20 seconds. The Google Compute Engine, because it's a machine, it's just a machine. The machine itself is just there and it needs certain images to run to allow you to have your application. These images are the operating system, and it has pre-built images where you can use Windows, Ubuntu, and various and other line of it. And it also allows you to upload your own custom images. So this is quite good when you have an existing infrastructure and you want to migrate to the cloud where you have your own ISO image. You can easily upload this and have it configured on Google Compute Engine for you. Also, the Google Compute Engine, each virtual machine can be managed in instance groups. And what this does is that it allows you to create templates where you can easily auto scale. So cases where you need more machines, where you need to auto scale easily, you can create instance groups and you can easily auto scale your workloads. It allows you to also deploy in various zones, ensuring that your application is close to wherever your users are. Yeah, so the use cases for the Google Compute Engine includes when you're trying an existing infrastructure to the cloud, where you're dealing with genomics data processing, where you have certain license restrictions, where you need to ensure you meet certain license requirements. For applications that need more network protocols, because you have the machine itself, you're able to configure it however it suits your purpose, where you need specific operating systems or where you need to configure your operating system kernels to work in certain ways. Also, the Google Compute Engine provides certain types of virtual machines known as the confidential virtual machines. This is very useful when you're dealing with uh, systems or applications that will be used in the health industry or financial industry. It ensures that your application's data stay private and encrypted even while in use. So some of the constraints is the speed. So the time it takes for your code to run is about 20 seconds. This may be negligible in certain cases, but when you need to respond to traffic spikes, this might be a bit on the negative side. So this might not be very useful when you want to start responding to traffic spikes. You want to consider products such as the App Engine. Also, the cons, you have to manage the software patches yourself, especially when you're using a custom image you have created. You have to deal with the software patches and ensure it is up to date security wise. It requires more developer experience because you have to have a good knowledge of the RAMs you need, the CPUs you need. You want to have an experience so you're not provisioning more than you need. Because when it comes to payments for the Google Compute Engine, you pay for the resources that has been provisioned. You don't pay for what you use. So at the instance where you're creating your resource, your virtual machine, you start paying per the hour for it. And even if you're getting zero traffic, you still have to pay. So having a good experience, having a good knowledge of how your applications will work would be very, very good to know which resource to choose. And a quick demo of the Google Compute Engine. uh, for creating an instance, it provides you the ability to select the machine types you want. These are like specialized workloads already. This is for general purpose, compute optimized, GPU optimized. You can select the GPU types you want, the number you want, and so much more. Also, you're able to configure the CPU on however you want it. This basically just allows you to have the machine as you would have it if you were to have it physically in your company or your house, however you want it to be. This is what the Google Cloud Compute Engine provides for you. By enabling the confidential VM service, you're trying to ensure that your application's data stay private and encrypted at all time. And this, as I had mentioned, is good for applications that will contain sensitive user information. You're able to configure your firewall, manage your disk, do some security, SSH management, because you have access, you are able to access your virtual machines via SSH. And if it's a window instance, you can use your remote desktop to access it. So this allows you to configure all those variables. So we've mentioned quite a number of compute resource, from cloud functions to Cloud Run to the App Engine, Google Kubernetes Engine, and the Google Compute Engine. So the question still comes that what compute resource should I use? And it totally depends. It depends on a number of factors. There is no right and there's no wrong. It just depends on your variables and whichever is best to fit into them. I'll be talking Um, I'll be talking about some of these factors to consider when choosing a product to use. Um, we'll talk about the usage type, the billing model, the technical requirements of your application, your team structure, and the current project stage. The usage type of your application really matters. You want to understand how it will be used. Is this an event-driven application? Is this an application that requires certain dependencies for it to run? Is this an application that must make use of concurrent programming? Is this an application that must respond to spikes, traffic spikes, and so much more? Understanding these would allow you to select the right product. For cloud functions, they are very good for event-driven applications, App Engine, web applications, and backends. Cloud Run is good for event-driven web applications. Of course, they have to be running on containers. Kubernetes Engine for your Kubernetes architected applications, and Compute Engine is quite good for um, existing applications running in other environments that you're trying to bring on the cloud. You want to explore the Compute Engine option. In terms of billing, for cloud functions, you pay based on usage. You pay based on the request made. The same thing for App Engine, you pay based on the usage. For Cloud Run, you pay based on the usage of the resources. This means that if there's no triggers, if there's no request made to your Cloud Run instances, you're not paying. But the moment you start getting requests, you pay for the actual resources used in terms of the CPU and the memory. For Kubernetes engine and compute engine, you pay for the resources used. So if by default you have two virtual machines running, the moment you have it set up, that is when you start paying for it. It's not usage based, and you want to consider this model when selecting the products to use. Also, in terms of technical requirements, when you're dealing with function granularity, you're just shipping out chunks of your application in forms of functions. Cloud Function is a way to go when you want to take full advantage of app versioning and being able to split traffic between app versions, being able to roll out your updates gradually. App Engine is a good way to go. Same with Cloud Run. And for Cloud Run, where you need support for other programming languages, you need some certain runtime dependencies. Cloud Run is good to use. For Kubernetes Engine, where you need managed clusters, GPUs for your AI workloads, you need much more flexibility in terms of network protocols, you would use your Kubernetes Engine. For the compute engine, this is quite adaptable to a lot of scenarios, but it's used specifically when you have to do certain configurations, certain startup scripts. You want to perform actions when you're starting up your instance. You have certain licensing requirements. Compute engine might be your best bet. And another factor to consider is your team structure. Is your team more development oriented? Is your team balanced? Is your team in your team, do you have people with systems engineering skill set? This is a very good factor to consider. So when you're just building an app, for an example, and you're more of the only developer, consider a product such as Cloud Functions because it allows you to worry more about your code instead of the mode of deployment. The same with App Engine. For Cloud Run is a bit in the middle because using containers means you must have some certain skill set to understand how your containers would interact with the underlying environment. And this is more of a balanced team structure. For the Kubernetes engine, it's very good when you have a full team with several teams being independent, managing a certain feature themselves. When you have like microservices spread out over various things, Kubernetes engine is quite good. For the computer engine, it's not, we can't say it's development focused or let's say more of systems engineering focused because it adapts to various team structures. And this is the reason you might be a development focused person you need certain dependencies for your application to run. Because of that, you can't just stick with cloud functions because your app won't run. So you have to go with compute engine, which gives you the ability to customize your environment the way you want. So finally, I'll be talking about the project stage. At what stage is your app in? Is it a new application? Is it at the ideation stage, or is it an existing application? When you're dealing with new applications, you want to start um, from the top to the bottom. You want to consider products from the top to the bottom in this diagram, because it's quite easier for you to architect your application to work with this product easily because you're just building it out. And you might want to consider it because it offers cost effective. It's quite cost effective. They are quite they have more features. They allow you to worry more about development and shipping your project rather than managing the infrastructure. But for existing applications, it is best to start ground up. You don't want a situation where you have a legacy app and you're trying to just split it out into functions. It will be quite hard and it will take much more time to do that. So for existing applications, you want to consider products such as the Google or compute engine. You go towards Kubernetes engine for your Kubernetes clusters that you already have before you start looking at these fully managed options such as Cloud Functions, App Engine, and Cloud Run. And so to answer the question, choosing a Google Cloud Compute resource, the answer is it just depends. It depends on a lot of factors, and understanding where you are, understanding your team, understanding the billing model that best suits your business would come in handy in selecting the right resource to use. And it's also worth to mention that all these all these products can be used together. There's no limit. You can use your app engine for certain services, use cloud functions for responding to some events, use compute engine for managing your AI resources, and then plug them into various Google app APIs that are available. Um, yeah, so I'm hoping that I've been able to describe how you can choose a Google Cloud Compute resource, and this will be the end of my talk.
Fantastic. That was awesome. Thank you, Samuel. Um, if anyone has any questions, feel free to type them in the chat. Sam, I don't know if you want to leave your LinkedIn or something. If anyone wants to chat with you afterwards, that's up to you. But yeah.
Okay, so I'm dropping in my LinkedIn profile. Anyone that wants to connect, please feel free to connect. And if you have any questions, I'll be so much glad to answer them.
Okay. Seems like everyone enjoyed your chat so much that they don't have very many questions. But yeah, if that's all, then good luck with finals, everyone. And thank you for joining our workshop. We'll hang around for a bit in case anyone has any last minute questions. All right. Seems like everyone heard your workshop loud and clear. Um, anyways, have a good night to everyone then. Feel free to reach out. I'm sure if you were able to join our workshop, you know what our socials are and what our contact information is. But I'll drop the GDSC website. That's where you can see where all of our upcoming workshops are. And Sam has his link in there. So if that's all, then have a good night, everyone. See you at the next one. Thank you to
Bye,
Sam.
everyone. Yeah.
Bye, everyone.
Bye.